Subject name is data structure. Unit number 1. Title of the unit is linear data structure list. Topics to be covered in this session is circular linked list, applications of list, polynomial manipulation. Circular linked list. In a circular linked list, the last node contains a pointer to the first node of the list. We can have a circular singly linked list as well as circular doubly linked list. While traversing a circular linked list, we begin at any node and traverse the list in any direction, forward or backward, until we reach the same node where we started. Thus, a circular linked list has no beginning and no ending. The figure shows circular linked list. Here there is no beginning and no ending. Operation to be performed in the circular linked list is insertion and deletion. Now we will see how to insert a new node. Inserting a new node in the circular list, in this section we will see how a new node is added into already existing linked list. We will take two cases and then see how insertion is done in each case. Case 1, the new node is inserted at the beginning of the circular linked list. Case 2, the new node is inserted at the end of the circular linked list. Case 1, inserting a node at the beginning of the circular linked list. Consider the linked list shown in figure. Suppose we want to add new node with data 9 as the first node of the list, then the following changes will be done in the linked list. First one is shown the original linked list. We want to add a new node which consists the data part value is 9 as a new node. Allocate memory for the new node and initialize its data part to 9. Take the pointer variable ptr that points to the start of the list. Move ptr so that it now points to the last node of the list. Add the new node in between ptr and start. Start point to the new node. Finally, we get a new circular linked list with the new node is inserted as the first node. Case 2. Inserting a node at the end of the circular linked list. Consider the linked list shown in figure. Suppose we want to add a new node with data 9 as the last node of the list. Then the following changes will be done in the linked list. First one shows the original linked list. Next, allocate memory for the new node and initialize its data part to 9. Take the pointer variable ptr which will initially points to start. Move ptr so that it now points to the last node of the list. Add the new node after the node pointed by ptr. Finally, we get a new circular linked list with a new node. Second operation of the circular linked list is deletion. Deletion also two cases occur. Now we will see the first case. Case 1 is the first node is deleted. Consider the circular linked list shown in figure. When we want to delete a node from the beginning of the list, then the following changes will be done in the linked list. Start always points to the first node. Take a variable ptr and make it point to the start node of the list. Move the ptr further so that it now points to the last node of the list. The next part of the ptr is made to point to the second node of the list and the memory of the first node is freed. the second node becomes the first node of the list. Finally, the first node is deleted after we get a newly circular linked list. Now we will discuss the second case, how to delete the last node from the circular linked list. Consider the circular linked list shown in figure. Suppose we want to delete the last node from the linked list, then the following changes will be done in the linked list. Start always points to the first node. The last node is connected to the first node. We want to delete the last node. So, take two pointer, previous pointer and PTR, which will initially points to the start. Move the PTR so that it points to the last node of the list. Previous pointer will always points to the node preceding PTR. Make the PTR's next part store start node's address and free the space allocated for PTR. Now previous pointer is the last node of the list. Finally, we get a new circular linked list with deleted last node. Now we are going to discuss about applications of list. We will see the applications of list, implementation of stack and queues, implementation of graphs. Adjacency list representation of graph is most popular, which uses linked list to store adjacent vertices. Dynamic memory allocation. We use linked list of free blocks. Maintaining directory of names. Performing arithmetic operation on long integer. Radix sort. Polynomial addition, subtraction and multiplication. Polynomial representation. Let us see how a polynomial is represented in the memory using linked list. Consider the polynomial 6x cubed plus 9x squared plus 7x plus 1. Every individual term in the polynomial consists of two parts, a coefficient and a power. Here 6, 9, 7 and 1 are the coefficients of the term that have 3, 2, 1 and 0 as their power respectively. Every term of the polynomial can be represented as a node of the linked list. Figure shows the linked representation of the terms of the above polynomial. First one represents coefficients, second one represents its power, third portion represents the connection between the two nodes. We will see one example to how to add a polynomial. Here the first number is 5x squared plus 4x plus 2x power 0. Second number is 5x plus 5. These two inputs are represented by using the list in the format. Finally, we are going to perform addition. We get a resultant list. The resultant list can be represented with the help of linked list like that. Here the node structure is coefficient, power, address of the next node. Polynomial multiplication. Here also we have two inputs, poly 1 and poly 2, which is represented in the linked list. Finally, we are going to multiply that one. The resultant value is stored in the linked list. Similarly, we can perform addition and subtraction also. The another applications of linked list is radix sort and multi-list. In radix sort, where linked lists are used, is called radix sort. Radix sort is sometimes known as chord sort. Multi-list, we have combined two lists into one. All lists use a header and or circular. Using the circular list saves space but does so at the expense of time.